Hey, this is Mr. Alexander, and I would like to talk to you today about IB Subtopic 2.4, which is Cumulative Frequency Curves. What we have here is a Paper 2 question. It says the cumulative frequency graph shows the speed s in kilometers per hour of 120 vehicles passing the hospital gate. And so we've got a cumulative frequency graph here. And part A says, estimate the minimum possible speed of one of these vehicles passing the hospital gate. You can always tell where this graph starts, the x-intercept, if you will. Since it starts at 10, the minimum possible speed is 10 kilometers per hour. Now, in part B, we're supposed to find the median. So what I like to do is I figure out what the total frequency is, which is 120. I go to the halfway point, which is straight across here, and then go straight down when I intersect with the cumulative frequency graph. Straight down. If that's 35, that's 36. So the median is always the 50th percentile. So I'd like to mark that as the 50th percentile, which makes that the median, which means that the median is 36 kilometers per hour. The next question, part C, says write down the 75th percentile, which is another way of asking us for Q3. Well, Q3 is always halfway between the total frequency and the median. So halfway between 120 and 60 is 90. So I'm going to go straight across here until I intersect the graph. And then I'm going to go straight down. And that appears to be 41.5 kilometers per hour. Now the last part of this page says calculate the interquartile range, which you might recall is Q3 minus Q1. We've already got Q3, it's 41.5. Now I need to find out Q1 to subtract it. Q1 is always going to be halfway between, if this is the 75th percentile, Q3 is, Q1 is the 25th percentile, so halfway between 0 and 50. So halfway between 0 and 60 is 30. Straight across, straight down. That's just about 32.5. So the interquartile range is simply 9. This question continues on the back. So let's see what else we got here. It says the speed limit past the hospital gate is 50 kilometers per hour. Find the number of these vehicles that exceed the speed limit. Alright, so I'm looking at my cumulative frequency here, and I'm looking at 50. If I go straight up from 50, and then straight across the other side, it's 110. Well, if there's 120 people total, I can just subtract off that 10. I'm only interested in these folks right here. There's just about 10 of them. 120 minus 110. There's 10 people who are speeding right now. Or 10 vehicles, I suppose. And now we've got a frequency graph that we need to answer some questions about. It says, the table shows the speeds of these vehicles traveling past the hospital gate. Find the values of P and Q. So we need to find this one right here and that one right there. Well, we already found Q in the previous problem, part E. The number of people going from 50 to 60 miles per hour, that was just 10. Now, to figure out P, we can go back to the graph and actually try to count the number of people between 10 and 20. But if we're smart, then we'll remember that there's only 120 people total. So we just take our calculator, we say 120 minus 0, forget about the P, minus 16, minus 64, minus 26, minus 10, then we're left with 4. So P must be 4. Alright? And with this information, we can figure out what the modal class is. Remember, the modal class is the one that occurs most frequently. So 64 is the highest frequency. The modal class must be 30 less than s for speed less than or equal to 40. Write down the mid-interval value for this class. Halfway between 30 and 40 is simply 35. And then it says use your graphic display calculator to calculate an estimate of the mean and the standard deviation. If we go to stat edit, and we're just going to type in what we know, what we don't know, or sorry, what we do know are these frequencies, so I'll just go ahead and type in the frequencies first. 0, 4, 16, 64, 26, 10. And now I can't type in 0 to 10, 10 to 20, 20 to 30, but I can type in the mid-interval value. So halfway between 0 and 10 is 5, 15, 25, 35, 45, 55. From here it's stat calc 1. My list is L1, my frequency list is L2. Go ahead and calculate that to get the mean, and I'm going to round it to 3 significant figures. The mean is 36.8, that's kilometers per hour. And the standard deviation is simply this symbol right here, sigma of x. That's going to be 8.85 kilometers per hour. Alright, now for the hard question. Questions like this are what makes paper 2 challenging. So I'm going to zoom in on it. It's proposed that the speed limit past the hospital gate is reduced to 40 kilometers per hour from the current of 50 kilometers per hour. Find the percentage of these vehicles passing the hospital gate that do not currently exceed the current speed limit but would exceed it and the new speed limit. So who are those people? The people who are currently not exceeding the speed limit but would be are the ones who are going from 40 to 50 here. So we're talking about these, we're talking about these 26 people, because they're not. The ones who are going from 40 to 50 now, they're not speeding. But if the speed limit was closed, or lowered, then they would be speeding. So we're talking about those 26. So to calculate a percentage, 26 out of the total, 120, make sure you multiply it by 100 to put it in percent form. That's about 21.7%. So that's paper 2 question. I want to show you a paper 1 question, and then we'll be done with this video. So I'm going to go on to the next one. It's another cumulative frequency graph. This one says the cumulative frequency graph represents the speed, kilometers per hour, of 80 cars passing a speed camera. Write down the number of cars passing the camera with the speed of less than or equal to 50 kilometers per hour. So I'm going to 50 here. I'm going straight across. There's exactly 10 of those cars, so the answer to part A must be 10. Part B asks us to complete the following group frequency table for S, the speeds of the cars. Well, we already did this 0 to 50, it's just 10. To figure out 50 to 70, I'm going to go back to my graph. So I'm going to go up here to 70. Straight across is 30. So I don't want to write a 30 though, because I've already accounted for 10 of those. So 30 minus 10, there's going to be 20 of those folks. They were nice. They figured out that 34 for us. So if we're smart, we don't need to refer back to the graph for this 80 to 90, because they told us there's only 80 cars total. So I can just simply do 80 minus 10 minus 20 minus 34 minus 4, and I'm left with 12 cars right there. The mid-interval value of the 50 to 70 interval, that's simply 60, and that would be kilometers per hour. And figure out the mean, now we can do that by going to stat edit, typing in all the mid-interval values, so halfway between 0 and 50 is 25, 60, 75, 85, and 95. Delete those, type in the new frequencies of 10, 20, 34, 12, 4, Stat Calc 1, make sure your frequency list is in there. The mean is 67.5 kilometers per hour. And the standard deviation is sigma of x, so that's 18.6. Alright, so that's how you read cumulative frequency curves, how to answer questions about them. Thanks for watching. We'll see you next time.